So next, let's move on to application layer protocols. This is typically what we're more concerned with as developers. I want to touch a bit on the client server model that we've sort of already been talking about throughout this course. I want to briefly cover RPCs, and then I want to go over some actual application layer protocols. We're mainly going to be focusing on HTTP and a bit on WebSockets. These are the main protocols that are most useful for system design interviews. Now, starting with the client server model, the main assumption that we've sort of been making, and you can tell by the drawing, is that the client is going to be some end user, for example, you or me, could be using some kind of desktop or laptop, some kind of browser on a machine, which is going to be making some requests to a server. This could be, for example, google.com. And after making a request, we expect that we get some kind of response back. So this is loosely the client server model. It's mainly as simple as it sounds, but there's a couple things I want to clarify: that the client actually doesn't need to be an end user. It doesn't need to be a browser. It doesn't need to be a desktop machine or a laptop or phone or anything like that. Client is actually a very general term. It basically means the one that's making the request. In the client server model, there's a client which actually initiates the request, and then there's the server, which is typically, not some end user machine. It typically is a computer in some kind of warehouse or data center or something like that. And the responsibility of the server is to serve requests. It accepts a request and then it fulfills that request. But the client doesn't have to be a user. The client could actually be another server. It could be a server over here instead of some browser. Servers are allowed to communicate with each other. If we had google.com, for example, might use some kind of third-party service, which is another server. So in that case, one of the servers would be taking the role of the client, and then another server would be the actual server that is responding to the requests. Next, if you haven't heard of it, I want to sort of introduce you to this term, which is RPC. It stands for Remote Procedure Call. This is essentially a concept we've already been talking about. When we talk about moving data between machines, part of that is knowing what data to actually move. We need these machines to be able to communicate with each other. We communicate via code. So the way multiple machines can talk to each other remotely, over a network, is via a remote procedure call. Remote means that there are two machines that are separated by a network. So, from the perspective of the client, this is a remote machine. We want to execute some procedure call on it, just like a function call, just like in our client, which maybe is in a web browser. We have some JavaScript code, and we organize our code into classes and functions and things like that. If we want to call a function, we can do so. But what if there is code on a server, on a remote machine that we want to execute? So if we want to run a function that's actually located on the server, for example, from the client, we are on youtube.com. We want to list all of the videos in our user feed. Well, to run that code, we can't do it from the browser. We don't have access to that code. The code that generates the video feed for us is actually located on the server, so we need to run code that is on the server. This green code, let's assume, is on the server, so we do so via a remote procedure call. Now, this is a very, very loosely defined term. What we talked about is pretty much all it means, essentially executing code over a network. I personally think it's sort of an outdated and kind of a useless term, but I'm mentioning this because all of the other application layer protocols are essentially at their core RPCs. We're executing code that's not on a single local machine. We want to execute code that's not just in the browser. We want to execute code that's on the server, so we can issue an RPC, which is basically from the client. It would basically be us executing some line of code that looks like it's local to the client, but underneath the hood, that call is making a network call. So for example, list videos. This could be a function from the perspective of the client, but the code for this function is actually written on a different machine. It's on the Google servers. And after we execute this, the Google servers will respond with that list of videos. And since this is so loosely defined, almost everything, in terms of network calls fits under the definition of an RPC. We're going to be focusing on things that are explicitly defined, things like HTTP, a protocol, which basically boils down to RPCs, and we'll also be talking a bit about WebSockets. Okay, now let's talk about HTTP, which is the protocol of the internet. So we've already talked about moving data between machines. That was the internet protocol, IP for short, and we took this system and made it reliable using TCP. So now we have a way of reliably sending data back and forth between machines. You can think of this as sort of the bare bones infrastructure that we actually need to build applications, but HTTP is a application layer protocol that's built on top of IP and TCP. This is what we actually have control over. Now, there's a lot we could talk about with HTTP, but I'm going to be focusing on the basics because that's really all we need to know. A lot of the really small details aren't super important, and they're definitely not worth memorizing. So we'll be really focusing on the big ideas. The single biggest thing about HTTP is that it's a request response protocol. So the client makes a request and the server responds with the response, or RES for short. Now it might make a bit more sense why we were talking about this whole client server model and about RPCs, because HTTP is just about sending some request to a server, and that request will have information about what we want to execute, what kind of code on the server are we trying to execute, and the server will run that code and then respond with what we were, trying to get, or maybe there was an error that occurred or something happened in between. But there are basically two pieces of this communication. The client initiates a request to do this. Now, under the hood, there is a TCP connection handle, there's the handshake, there's all that. So it's important to know that HTTP is built on TCP and all the overhead and cost that comes with that. But as developers, we don't really see that. There's no state management between the client and the server. Everything needed for the request and the response is, handled in that request and response. The client and server don't need to know anything about each other other than what's already included in the request. And I think the quickest way to learn about HTTP is just to show you. So let's go to youtube.com and do a quick demo. The first thing you probably already know is that HTTP is used pretty much every time you search for something or land on a web page. In this case, we actually have HTTPS, which is a variation of HTTP. This is what is commonly used. It's pretty rare to just use the bare bones HTTP nowadays because it's less secure. But you'll see if I take away the S and then press enter, it'll redirect us back to HTTPS. Most websites do that by default. But what I want to show you is the network tab. So if you right click anywhere and you see inspect, this is your browser's dev tool. You may already be familiar with this, but you can go to the network tab and then see all requests, all network activity that's going on from the site that you're on. Let's go ahead and search for NeetCode and see what happens. The actual site isn't super important, so I'm going to cover most of that up here. But here you can see all the list of requests that are going on. And this is probably intimidating if this is your first time using DevTools, but this is the list of requests. So this is like the name of each request. I'm going to kind of close this. Most of these are HTTP requests, and we can sort of filter these by name, status, type, initiator, all these things. I'm going to go ahead and right click and then reveal the protocol. This is kind of what we've been talking about. So this says H3. That stands for HTTP version 3. There are multiple versions of HTTP. I'm not going to go super in depth to that, but HTTP 3 is the most recent version. And now actually looking at one of the requests here, this one, results, let's get into the anatomy of an HTTP request. So one component is the headers of a request. Every request has two main components. One is the header and another is the actual body of the request. So there's actually three groups of headers. One is the general header. This includes some really basic stuff like the actual URL that we're making a request to. So when we type, youtube.com into our browser, we're making an HTTP request. Here, when we searched for NeetCode, we also made an HTTP request to youtube.com. So that's like the base URL. And we also have a path here. So results with a query of NeetCode is how we landed on this page. There's a couple more important fields like the request method. So in this case, we made a GET request. There's a few more really common request method types, namely post, put, and delete. There's a lot more, but those are the four most commonly used. And we also have status codes. So 200, green in this case, you can kind of tell that this was a successful request, also because the page actually loaded with the list of videos. But that's the main idea here. We're kind of familiar with this concept of a header by now. It's used to kind of give information about the request itself. How do we know where this request even needs to go? Well, it's going to this URL. What kind of method are we using? We're using get because we're trying to retrieve some information. Post would, on the other hand, be used to update the server. But we also have two more groups of headers, the request header and the response header. As the name implies, the request header is what the requester, the client, is actually going to set. You can see the authority is, the base URL that we sort of talked about, the method get, the path, which we specify as the client. We decide what we're going to look for, what kind of information we're trying to get, except there's several more fields here. We won't be covering all of them, but you can take a look yourself, and you definitely don't need to memorize all of these. We're kind of covering what you really need to know anyway. Another few are user agent. So this kind of says multiple browsers, but in my case, I'm using Chrome. And there's also accept. This is the data format that you're actually going to accept. In this case, we're getting an HTML page. You can tell that from the response here, doc type HTML. This is basically the HTML page that we're viewing after we type, something into the search bar. But going back to the headers, that's the request header. That's what the requester will set. Now the response also is going to set some information. So the response header will say, what content type was actually returned. The request header gave some options of what content, but ultimately the response includes some HTML. That's what text HTML means. So now let's actually review some of the things we talked about and go a little bit more in depth. So we know every request has to go to some URL, for example, youtube.com. Suppose that this is an API. This would be referred to as the API route. So this URL defines a route. Now this route could actually serve multiple HTTP methods. We could make a GET request to this route, and this would be its own endpoint. That's the term that's used to define, API, functionality with HTTPS. So this would be referred to as an endpoint. This is its own endpoint. This is the GET endpoint for this URL or this route. We could also have another endpoint using a different HTTP method. So we'd have some different functionality defined for the post method. So with GET at youtube.com, maybe, the server is going to return the HTML page for YouTube. Maybe post, though, would do something else. I don't know. Maybe it creates a user account or something to this exact same URL. We're using a different HTTP method, and that is going to do some different functionality. So this is going to be its own separate endpoint. That's what it's called if you're wondering about the terminology. So what exactly is the significance of these HTTP methods? Well, there's actually not a lot to it. I mean, the names themselves are pretty self-explanatory. I think GET, you typically use GET to retrieve some information. So if we're getting, the YouTube homepage, that would be one thing, or maybe listing a bunch of videos as we did earlier by typing in some query like NeetCode. Now, if you really wanted to, you could use an HTTP GET endpoint to create data. We could use GET to maybe create an account if we really wanted to and pass that information in the URL, maybe, the password and username in the URL itself, though we probably wouldn't want to have the password in the URL. That's not very safe. If somebody were to inspect the URL, they would see that information. So we would rather use a post request, and that's exactly what post is for actually creating information. So creating a user account or creating a comment or uploading a video, doing some kind of creation on the server is what a post request is for. And, the restriction with GET requests, actually, we talked about how the anatomy of an HTTP response, it has a header and also it has a body. Well, actually, GET requests don't have bodies. So if we wanted to create an account, we could not pass that information into the body. GET requests don't really have bodies. They only have headers. Everything we pass in has to be in the header. That's why we have to include any extra information in the URL of the request with a GET request. But post requests and the rest of these HTTP methods don't really have that restriction. They have a body, which we can pass additional additional information into. So going back to the network tab, I found a random post request that's being made. I think this is for some kind of, analytics data for YouTube. It's API/stats and then, this long string. But heading over to the payload tab, this is the body of the request. So there's a bunch of parameters here and some actual data here that you can see. Not super readable, but this is the idea. This is a way for us to pass any type of data we want in the body. Like we could pass in what kind of account we're creating. If we're leaving a comment, that could be passed here. Basically any type of form submission, anything like that. It's very flexible. So put requests are pretty similar to post requests. The main difference being that put is basically an update. So you can think of these HTTP methods as being sort of CRUD, where CRUD stands for create, read, update, delete. So with that, post would be creating, get would be reading, put would be updating, and then delete is, of course, deleting. There's a few other differences between the HTTP methods, the most significant being that these work a little bit differently with caching. Get, we would expect to be idempotent. If we're, reading some resource, we don't expect that resource to change. So get is typically idempotent. It's more cacheable. With post, we're creating a resource on the server. So this is definitely not cacheable. It's definitely not idempotent. After the first time that we issue a post request, it will continue to do some, action on the server side. So this is not idempotent. Delete usually is idempotent, so it's more cacheable. But this stuff isn't super significant, and I don't think you really need to know it. We also talked about status codes. That's essentially for the client knowing how the request was actually handled. Like maybe we made a request to youtube.com, but for some reason the server is having a problem and it can't fulfill the request. We would get some error code for us as clients, as users, to know what went wrong. Was it a server problem that happened? Or maybe we made a request that was invalid. Like maybe in the youtube.com search bar, we, use some special characters that we're not supposed to, some star or something. And then with that invalid string, the server, tries to parse it, but it says, this is invalid. I'm not going to respond to this type of request. And it would send that information to the client. Like, you made a mistake. This is not my fault. This is because you gave me an invalid string. And so I can't do this. So the client should know, was it my fault or was it the server's fault? Or, what exactly happened? Maybe the request and the response was perfectly valid. How do we know that? That's why we have status codes. This is part of the HTTP protocol. And as you can assume, this would be pretty helpful for developers. We don't need this at the TCP level, but at the HTTP level, this is very useful for us, though this isn't actually required. If we wanted to, we could send very unhelpful status codes, and some people do, but that's not good API design. You definitely don't need to memorize the exact status codes, but I think, knowing that 200 is a successful response. So, status code 200, which I think we saw earlier, is okay. Basically, that means the request was okay. There's another status code 201, which basically means a resource was created. So not only was the request okay, which we know from it being a 200 level code, but whatever resource we were trying to create, maybe we were adding a comment to a video, it was created successfully. You can assume that this would probably be used for a post request rather than a get request. And then a couple more that we sort of talked about. Client error. Code 400 would be for a bad request, sort of what we talked about with an invalid string. 401 would be for unauthorized. For example, we're trying to delete a video that's owned by some other user. We're unauthorized to do that. Maybe we're not the creators of that video, so we can't delete the video, of course. This would be the status code for that. We could also use bad request if we wanted to, really, but this is just a bit more specific. And there are other codes, 404 for a resource not found. You've probably seen that in your browser before. There's also 500 errors, which are usually more rare. The most common would be something like 500, which is an internal service error, or 502, which is a bad gateway, or 503, which is, just the service is unavailable. But at the very least, I hope this gives you a high level overview of what HTTP is all about. It's really for us developers being able to execute some code remotely and then get a response, just like we're executing a function as a part of, our own code base. The last thing I want to quickly cover is SSL/TLS. So this is where the HTTPS actually comes in, that, last character, which actually reminds me, we didn't talk about what HTTP stands for because, to be honest, it's not super important. It stands for Hypertext Transfer Protocol, and the last character S, stands for secure, or it could could just be HTTP with SSL. The relationship between SSL and TLS is that SSL stands for Secure Socket Layer. It came before TLS, but people still use the term SSL even though it's outdated at this point, and TLS is much more widely used. TLS stands for Transport Layer Security, and we'll only be talking about this at a high level because it's not super important for system design. The main idea is that HTTP is not necessarily secured against something called man-in-the-middle attack, MITM for short. Basically, if we're sending data, we know we have IP, we have TCP, and now we have HTTP and adding the S to make it secure. Because if we are sending data, just like sending mail in maybe a cardboard box, where that box is transparent, where you can see, maybe we have, a bag of money in here or something like that, right, in the box. If we're sending boxes that are transparent, anybody who sees the box in transit can steal it. They can see exactly what's inside and then open it up and take it. So that's where SSL and TLS comes in. If we're sending information on a site, we want that information to be encrypted. So from the client, if we enter our password 1234, for example, and then send it to the server, anybody in the middle of that HTTP request can see it. And we won't go into exactly how that might happen, but the idea is that networks are not very reliable or secure. Anything could happen. You could be at a coffee shop using public Wi-Fi and, those HTTP requests could be monitored and someone could see that your password is 1234 in the middle. That's a man-in-the-middle attack. SSL and TLS basically will encrypt anything that you send over HTTP. So if our password is 1234, this will actually be encrypted to be some kind of hash or something, let's say it's XYZ. So even though our password is really 1234, that will become some other string like XYZ, and that will be sent to the server, and the server will be able to decrypt it and then understand that the real password is 1234 and then use that. And if for some reason it was sending this data back, it would encrypt it and turn it into, XYZ. That's at a very, very high level because I think we've already spent enough time talking about the most important parts of HTTP, and most people just take the S for granted. It just adds security. For example, if you were on a site like this, Never SSL, at the top left of your browser, you'll see something like "this is not secure." That doesn't necessarily mean you're going to get a virus or something from the website. It just means that any data you send to this site, like your password, for example, you should be really careful about that, because if somebody is eavesdropping in the middle of the connection between your browser and the server of Never SSL, they will be able to see everything. But in this case, I'm not going to be entering any data anyway. So this site, the fact that it's not secure isn't really a huge deal. And the warning message here kind of implies as much. So having gone through all this talk about networking and protocols, we finally arrived at a solution, HTTPS, which is reliable and is easy for us programmers to use, and it's also secure, and we can use it just like we're, executing functions locally. It just happens that it's happening over a network on a different machine. But using these concepts, we can build very, very powerful applications.